The iOS Wallet app allows users to manage payment cards, boarding passes, tickets, gift cards, and other passes. Passes can also be updated using push notifications, making it easy to keep the user up to date with the information on the passes. In this video, let's learn how to set up, build, and distribute Apple Wallet passes using .NET application. I will be using an AWS Lambda function to host the API endpoint to distribute the wallet pass, but you can use any of the existing hosting mechanisms that you use for your applications and your APIs. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos around .NET, Cloud, and DevOps. This video is sponsored by AWS and is part of my .NET on AWS series. Without much delay, let's get started with Apple Wallet passes. Passes are digital representation of information that might otherwise be printed on small pieces of paper or plastics. Passes can contain images and barcodes, and you can update it using push notifications. Here we have a high-level flow on how the passes are set up, distributed, and managed. Here you can see the server creates a pass and it installs via a URL, email, or a custom app. Many of us might already have used this in one form or the other. Once that is done, this pass is static on the client's app device. However, if there are changes for the pass on the server, they can be notified using a push notification to the user, and then the user will automatically update the pass from our web server. In this video, however, we'll be looking at only the first part where we create a pass and then the user can install it via an API. Now this can be also passed to an email or also from an app. When talking about a pass is nothing but a set of files that gets bundled into one single file. Now, the files that make up a pass are arranged in a package which is called a bundle or the pass package. Now, the main file that includes all the information and data that gets shown on the pass is in the pass.json file. Additionally, there might be images and thumbnails, etc. that's bundled as part of this pass file. We will see all these files as we build our API and start distributing the pass. So let's switch over to Visual Studio and start building our .NET pass. I have a solution already set up with the Lambda annotations framework so that I can easily set up an API endpoint. If you're completely new to Lambda annotations framework, you can check out my video which will be linked here and in the descriptions below. The annotation framework provides these attributes, Lambda function, and also the HTTP API, which is all we need to attribute this function with to make this an API endpoint. Now in this case, this is a get endpoint and it is on the root path. So let me fix this and make this on the Apple Wallet path so that we know this is for Apple Wallet. Now to make the annotations framework, there are a couple of NuGet packages. So let's right click on this and say manage NuGet packages. And here you can see the lambda.annotations framework and also the Lambda API gateway events already installed. Now to work with Apple Wallet passes, we need to add another NuGet package. Now there is a package .NET-Passbook which is available on GitHub as an open source. This is a .NET standard library for generating passbook packages for iOS Wallet. So let's navigate back to our application and add this new NuGet package. So let's search for .NET Passbook and let's add this package into our application. Now once the package is installed, let's navigate back to our functions.cs and let's add the code required to generate the pass. Now let's assume the pass that we are building is for an event order ticket. So let's say we have an order ID and also an event ID for which the order was placed, and that is where we are going to generate a pass for. So let's take in these parameters as part of our URL. Make in the order ID come as part of the path parameter, and also let's have the event ID come in as part of the path parameter. Now in this case, we can simply bind to it using the Lambda annotations framework by using the same name. So let's take this as the string order ID and also the string event ID. Now once we have the order ID and the event ID, let's use this to build our pass. Now to start building the pass, we need to first create a pass request. So let's generate a pass request using a different function. So I'll simply write a function here. Let's make a new method, which is passRequest, and let's simply return a new PassGeneratorRequest. Now this is going to come from the passbook.generator NuGet package that we just added. Now this is going to be for the order and the event. So let's take in that as a parameter. So let's take the order ID and also let's take the event ID as parameters. And let's make sure to pass them in here. We will come back to this method in a moment. So once we have the request, we can use a generator again coming from the same NuGet package. So let's use the generator is equal to new PassGenerator, and let's create a new instance of that. Now we can use the generator.generate method and pass in a PassGeneratorRequest. And let's pass in the generator request that we have already created into this method. For this method, let's make sure to return the PassGeneratorRequest as the return type. So let's make sure that, and that gets fixed. Now the generate method is going to return a byte array, which is the pass bundle. So let's get that. So let's say the pass bundle is equal to that array. Now we have generated the pass bundle, which we need to return back in this API endpoint. Now since this is going to be a file, I need to return this as a binary content. So for this, instead of the default string type, I'm going to default back into the API gateway HTTP v2 proxy response. Now this is the native underlying way to respond for an API request. Now I'm not sure with the annotations framework if there is another way for returning binary content. If you know of one, please let me know in the comments below. Now to generate this response, so let's create a new type. So let's say return API gateway response, and let's create this type. So in this case, the body is going to be the pass bundle. Now, since this is going to be a binary content, we need to convert it into base 64. So let's say convert to base 64 string and pass that array. Let's specify the is base 64 encoded is equal to true. Let's also specify the status code to be 200 because it is a successful response. And let's specify a few headers. Now the headers is going to be a dictionary of string. So let's create a new dictionary and let's create a string dictionary. Now inside this, we can specify the content type. Now for Apple Wallet passes, it is going to be application/vnd.apple.pk passes. Now the PK passes is used when you have more than one pass that you're returning back. So if you navigate back to our NuGet package, you can either use PK pass or you can also use PK passes if you have multiple pass files. So you can have multiple pass files by generating multiple requests. So in this case, if you were to return an array here, and if you were to return an array of requests, then that's also going to create multiple pass files, and you can use the PK passes as the return type. So let's for now return a new array and let's return multiple requests back. It's very likely that for an order, you might have multiple tickets and you want to return multiple passes in the same response. So let's leave it like that. And the generate method does take in an overload for one request and also multiple requests. So we don't have to make any changes there. Now, once we have set up the content type, let's also specify the content disposition to set the appropriate file type for this return response. So instead of me typing it out, I'll copy and paste this. And all I have said is the file name is tickets.pkpasses.zip, and also it is in the UTF format and it's specifying the details for that. So once I have this, let's close the bracket, and this is going to return the response inside this API gateway response. Now for this to be a dictionary, let me make sure to wrap this as a key value pairs. So let me use a braces for that. And let's also use a braces around this header key value. Instead of colon, let's make sure to use comma. And let's make the same in here. And now this compiles successfully. Right now, we have the base function that's getting the pass request, generating the bundle, and then returning the response. Let's now add in the code to generate the pass request. Now, this has a few attributes to be set. So I'll first copy and paste the code and then walk you through it rather than you having to see me type through. So let's remove this and let's paste this in here. We have an event name. So I have set it up as a YouTube demo event. And the venue name is YouTube Online. Now we also have the event date, let's say, which is 55 days from now. Now I also have injected in Apple Wallet configuration, which I will come to in a short while. So I'm just getting the icons and logos from a configuration file. We are generating the pass generator request like before, and we are setting up the pass style to be event ticket. Now there are different pass styles that you can use, like from boarding pass, store card, coupon, generic, etc. In this case, since this is a ticket for an event, I am setting it as event ticket. Now there is a pass identifier, which is also coming from the configuration file. This is the identifier that we use to register in the Apple Wallet, which I'll show you in a moment later. Now the serial number is nothing but the identifier for this Apple wallet. Now in this case, if you have multiple tickets inside this order, the serial number would be the ticket's ID, or any identifier that is used to individually call out each of the passes inside the bundle that we are going to send back. Let's create a new var ticket ID and set up that as a new GUID and use the serial number as the ticket ID dot toString. Now the grouping identifier makes all the passes to be shown as a single group inside the Apple wallet. Now in this case, since this is for an event, I am grouping it by the event. So even if you purchase multiple tickets over multiple orders, it will be all in a single group. You can also set up the background color, the label color, and the foreground color explicitly. Now the images takes a list of icon and logo images, which I am setting it up, which is coming from this configuration. Now the description is the event name and a few other properties that I have set. Now the other two important properties that is required is the Apple WWDR CA certificate and also the passbook certificate that is used to sign this pass file. Both these certificates are coming from the configuration file. Now again, you can set up some header fields, the primary fields, and also information on the back of the pass. So I'm setting up some default properties in there. Now since this is returning an array, so let's create a return new of array and let's pass back the request. Now if you have multiple tickets inside this order, you would be looping through these number of tickets and creating this request and generating the array of request. Now since we have only one, let's keep it like that. And let's look at the Apple Wallet configuration. Let's create the new class Apple Wallet configuration inside our solution. So I have the class already created. So let me copy and paste that in here and let's walk through that. Now the configuration has the certificate base64, the pass type identifier, the passbook certificate, which is our certificate, and also the passbook password. It also contains the logo URL and the icon URL, which is getting converted into bytes async. Now for this get bytes async to work, it is coming from the flurl.http. So let's right click, add a new NuGet package, and let's add the flurl NuGet package. So let's go to browse and let's search for flurl and let's install the flurl.http. So this library is to interact with HTTP and it makes it very easy to make HTTP request. If you want to see a video on that, let me know in the comments below. Now let's come back to the configuration and let's make sure to add the appropriate using statement. So this takes in a string URL and gets the byte async from that. So both of these functions are returning the logo as a byte array. Now once we have the configuration class set up, let's create the app settings.json file in the Apple wallet. So let's create a new file. So let's say add new item and let's say app settings.json. Let's right click on the file, make sure that gets included inside as content and it's also copied as new, which means it gets packaged into our output folder. Now once we have the app settings.json, let's add in the appropriate properties. So let me copy and paste that. Now we have the Apple wallet configuration, which matches the class name that we have, and we have the properties that also match the names. I also have the logo URL and the icon URL. Now the pass type identifier, certificate, and password is something that you get by registering in the Apple developer portal. So if you navigate back to the NuGet package, if you search for the certificate section, which is on the top of this, and look at the instructions here, you can see how you can build and set up these certificates in the Apple developer portal. So if you navigate to this instructions on the blog, you can see the full details on how to generate the certificate, upload it to Apple, and get it verified and download the password. So you'll need to do this process separately and get the password and the certificate and put the appropriate details back in our settings file. Now I have stored the passbook certificate as base64 encoded, so you can do the same and put it inside here. Now when you register in the Apple developer portal for your Apple Wallet pass, you will get the pass type identifier. So in this case, I'm also using that. You can also store this inside the secret manager or even the parameter store and have your app download it from there. I have other videos inside my .NET series which will show you how to do exactly that. Now once we have the Apple Wallet configuration and the app settings.json file, we can register this using the options pattern in the startups class. Now the startup class is also coming from the annotations framework, which allows us to do dependency injection for Lambda functions. So in here you can see you can configure a iService collection which gets injected into this function. This is used to dependency inject and resolve things that's required by our function class. So let's say inside our function class, so let's create that. Let's say we are going to use the options pattern. So let's say options. Let's use the options snapshot and let's specify Apple Wallet configuration. And let's specify Apple Wallet configuration as the value here. Now, since this is already using the Apple Wallet configuration, let's create a property inside our class. So let's say Apple Wallet configuration underscore Apple Wallet configuration. So we have the property required, and let's set that inside this constructor. So let's say Apple Wallet configuration is equal to this dot value. So we have the value appropriately set for this function to use. Now, since this is an await method, we'll need to make sure to convert this whole function to an async. So let's say make method async, and that will automatically do that for us. Now, since I have made this as an async, let's make sure to await this call as well, which means it flows up to our main Lambda function as well. So let's make that as well an async method, which returns a task of the same response type. Now, once we have done this, let's come back to startup.cs. Let's turn on the configuration builder. So let's uncomment this code, which creates the new configuration builder and uses the JSON file app-settings.json. Now, once we have the builder, let's create and inject the instance for that into the services collection. Now, you can also turn on the options pattern by using services.addOptions and specifying the type. So in this case, that is going to be the Apple Wallet configuration. And let's bind this configuration using the name of the type. So let's say name of Apple Wallet configuration. So it uses this name to find this configuration section inside the app settings.json file. So that's why we have named it as Apple Wallet configuration. Now, if you're new to options pattern, I highly recommend checking out my video, which will be linked here and also in the descriptions below. So now once we have all that set up, let's make sure to build this and make sure this is building fine. Now, once that is done, let's go to the Solution Explorer, right click on our project and say publish to AWS Lambda. Now, since I'm using the annotations framework, it has created the serverless.template file automatically for me, and it uses that to deploy it to our AWS stack. So let's name this as Apple Wallet and let's click publish. So this uploads this template file into that S3 bucket and then deploys that template into this stack. So let's wait for this to complete to navigate to our endpoint. The deployment is complete, and I have also set up the appropriate configuration settings for the passwords and the certificates inside my Lambda function, and I can navigate to this URL. So let's navigate to the appropriate endpoint for this Apple Wallet. So let's go to Apple Wallet and pass in the order ID and the event ID. So let's navigate here. So let's say Apple Wallet / let's say the order ID as ABC123. And let's say the event ID is XYZ123. Now, once that is hitting this endpoint, it is going to generate the file for us in the background, and it is going to automatically prompt us to download that file. Now, in this case, since I'm accessing it from a different browser and not an Apple Safari browser and also not on a device, it's prompting me to download this. So let's save this to my local and open this folder. Now, this has a pk pass file, which has all the contents that we saw. Now you can open this file also as an archive. So let's copy this outside to my downloads folder and let's open this with the 7-zip. So let's say open archive, and you can see all the files inside that archive file. So here we can see the pass.json, the manifest.json, the signature, and also the logo and icon files as part of this pass package. Now, you can also see the JSON file if you want. So let's navigate into the pass.json file, and you can see all the details inside here. So you have the foreground color, the background color, label color, etc. like we said, the grouping identifier, the key names, and also the pass backfields, etc. that we set in the request. Our library is automatically doing all of this and generating this pass file. So let's share this URL and open this from an iPhone Safari browser and see this in action. Now, when I navigate to that URL inside the Safari browser, it automatically prompts up to add this wallet to my pass. So it shows the information of the pass to me, and it has the add and cancel button. So if you choose add, it is going to add this into your Apple Wallet. So if I navigate into the wallet app, so let's search for wallet and navigate to that, you can see this wallet pass added here. So if you add more passes, it is automatically going to show up under here. Now based on the grouping identifier, it might show as the same group or as different group. Now this wallet pass inside our wallet is a static file. Now it doesn't get updated. If you want to update this pass as changes happen on the server, we will need to enable push notification and also have this pass talk back to our web server. That will be a topic for another video, and if you're interested to see that, let me know in the comments below. I hope this helps you to set up, build and distribute an Apple Wallet pass using a .NET application. We saw how to set up and create the pass using the NuGet package, and we also saw how to set up the certificates and get that from our application and get it injected into our function. Now you can use any hosting mechanism that you already use, and you can also build this API in an ASP.NET Core API. Most of the code will remain exactly the same. If you like this video, please make sure to hit the like button. If you want to be notified of future such videos, please hit the subscribe button. It also helps me to grow this YouTube channel. Thank you and see you soon in the next video.